All right. Hey, good morning, ladies and gentlemen. Funny story. I've recorded this video once already now, but it turns out I recorded it without any audio. So it was a whole 15-minute video of just my screen with no audio, blank, and oh my gosh, so frustrating. But we're going to try and get through this. So what I wanted for you guys to do today asynchronously is essentially go through your digital notebook and take one page of notes for me. Of course, you're going to do that with me, and I'm going to explain the notes and we're going to talk about them. But I apologize if this comes out a little late because I anticipated the 15-minute recording I made earlier was going to work, but it's not. So I'm busting out a quick one real quick right here. This is your notebook, right? Of course, you're assigned this in Schoology. You can do whatever you want with your name, your notebook, whatever. Um, as usual, we have our learner resources, right? How to write a CER. You guys know how to do that. We have a textbook link. We have your link to your periodic table. You guys see me use this all the time. I love it. And then we have our link to the class Quizlet that just has a lot of nice words there that you guys might need to cover or know. As for the learning targets, right, these are going to be really confusing to you right now and just honestly might overwhelm you. So I say just ignore them right now. Just ignore them for right now. Excuse me. It's been a long morning. But here's what we're going to start talking about. And it does seem a little scary to think about it, but we're going to start talking about something called quantum mechanics. Now, usually when you guys hear this word, you're like, oh my gosh, that's from Star Wars or that's from Star Trek, right? That's some sci-fi word, quantum, Rick and Morty, right? We're never going to talk about that. But it turns out that word's not as scary as TV shows make it sound. It basically, it's just a relative term to how you use it. There's some videos that help you understand a little bit more about what we're talking about. But trust me when I say it's not as scary as you think it might be. So, I recommend watching some of these videos before continuing and going through the notes. First thing we're going to start with today is this page, and I have some pictures over here that'll kind of help us work through it. But we're going to talk about how we order electrons. So we've been using the metaphor of the boarding house, and then you guys even did some practice on actual Bohr models. We're going to talk about exactly how this is ordered because it's not just like throwing dots on a line. It's very much more specific than that. Similar to how it's more specific than just putting campers on a floor, we have to put them in certain bunk beds, we have to put them on certain rooms, and everything like that. But before we get into that, we want to talk about just the general basics. And when we talk about Niels Bohr, we of course know we're talking about his model, the Bohr model, which is this one right here. Remember, this was one of the few models that we talked about in the last unit. He discovered that electrons are found in different blank. Well, he discovered they're found in different orbitals. Different orbitals, which are just these rings, right? These rings, orbital 1, orbital energy level 2, 3. Same thing as the floors. This is floor 1, floor 2, floor 3. We have our ring 1 and our ring 2. Each level or each floor, right, has a different energy level, a different amount of energy. The energy level blank to the nucleus is lower in energy. Well, it turns out the lower one, so the one that's closest to the nucleus, right? So the same thing is here, the closest to the ground, this one floor right here, right? That's the least amount of energy. It takes the least amount of energy to get to this first floor. Think about it. If you had to go to the second floor, you'd have to go up 2 flights of stairs. I'm not going to do that. That uses way too much energy. I'd much rather be down here. So this ring 1, the closest to the nucleus, is going to have the lowest amount of energy. Now, when we talk about what is quantum, right, we're going to use a very general description of it because it's just a lot easier for us. When we talk about quantum, it is just the amount of energy needed to move an electron up one level. That's it. So if I were to take this electron right here, this blue guy, I were to grab it and I were to force it up to here, that costs me a certain amount of energy. That energy is known as a quantum, right? Just a quantum. And we'll talk a little bit more about that when we get in person, but I don't want to just overwhelm you guys with that kind of stuff. How do energy levels, sublevels, and atomic orbitals relate to each other? So this is how we can break it down in the sense of our boarding house. So an energy level is a floor, right? Floor 1, floor 2, floor 3, and then we'll talk about a fourth floor too. Floor 1, 2, and 3. That's our energy level. If we look in the atom, that's just the ring. So we have ring 1 and ring 2, right? Floor 1, floor 2, ring 1, ring 2. Sublevels, those are just the rooms, right? We have the s room and the p room. Well, we have the s orbital and the p orbital. S orbital and the p orbital, right? S room, p room, s orbital, p orbital. And then we talk about atomic orbitals. That essentially just means the bunk beds, right? The bunk beds are an atomic orbital. So in the S room, we have one bunk bed. In the P room, we have three bunk beds. So that means the P room has three atomic orbitals, so the P sublevel, right? We're just using these words interchangeable. So the boarding house model is actually really good to kind of intro you to these topics. So let's talk first about this chart we see here. So this chart actually breaks down in terms of floors or levels, energy levels. So N1, that's like saying floor 1. N2, that's like saying floor 2, and so on. So let's just break this down because we know this stuff. It's just putting it in a different vocabulary. So principal energy level 1, right? N equals 1. Principal energy level 1. That's going to be ring 1, right? Or floor 1. Now I ask, how many sublevels are there? Well, if we look here on this model, we see there's only one room with campers. So that means there's only one sublevel, right? We see this, we see one sublevel, one pair, one. And each sublevel can hold their own amount of electrons. The special thing is this sublevel, right? This is an S room, so it holds S, sublevel S, right? I'm going to actually make sure this is all centered, right? Sublevel S. So we have the S suborbital right here on the first floor. Okay, cool. Now the number of orbitals, right? The number of orbitals is basically how many bunk beds are there, how many pairs can we have? So we can only fit one bunk bed, so our answer here would be 1. And then the total number of electrons we can fit, well, we answered what are the total number of campers we can fit on floor 1? If there's only one bunk bed, right, we can only fit 2 campers. 2 campers, we'd have 1, and then we'd have 2. Same thing is true for the atom here. This first level, we can only fit 2 electrons. All right, let's move on to our second floor. So our second floor, we see we have a few spaces. Our second floor, we have 2 different sublevels or rooms, right? We have the S and we have the P. So let's write that down, right? We have our S sublevel, which is this guy right here, and then we have our P sublevel, which is right here, our S room and our P room. Now, if we were to talk about the number of orbitals, the S is never going to change. I were to ask you in class, how many orbitals are in the S sublevel? And you'd see this one bunk bed, or you'd see this one pair right here, and you say, well, Mr. Payne, there's just one. And that is absolutely true. Now, the P rooms are different, right? How many orbitals are in the P rooms? You have to count the bunk beds. 1, 2, 3. So we have 3 orbitals, right, in the P room. Now we have to figure out the total number of electrons or the total number of campers, right? The way we find it is we take all of the bunk beds, 1, 2, 3, 4, on that floor and multiply it by 2 because, of course, we can fit 2 campers in one bunk bed. So we have 2, 4, 6, 8 total camper spots or 8 total spots for electrons. 2, 4, 6, 8. Now this only shows 1 on those ones, but if it was full, we'll show that later. Now, n equals 3 is a little different because our third floor in the boarding house model actually only showed 2 sublevels, 2 rooms, right? The S room and the P room on the third floor. Well, it turns out there's another room. There's a third room. So first let's fill out our S room. We know that's there. How many sublevels, or excuse me, how many orbitals, right? Well, we have 1 because we have the S room, or we have 1 bunk bed in the S room. And then for our next one, we know we have the P room, so our P sublevel is right here. How many bunk beds are in there, or how many orbitals fit in the P? Well, 3. Okay. And then finally, this is something you guys don't know. We have next our D level. D. The D level can actually fit 5 bunk beds. And I call this the dark room. That's why I put it up, because these guys are always sleeping. This is the dark room, and it fits 5 bunk beds. So if we have one room with 1 bunk bed, right, 1. We have 1 room with 3 bunk beds, 1, 2, 3. And we have one room with 5 bunk beds. 1, 2, 3, 4, 5 in here. 5 plus 3 plus 1 is going to be 9, right? 5 plus 3 is 8. 8 plus 1 is 9. So we have 9 total bunk beds. So how many total campers can we fit? Or how many total electrons? Because it means the same thing. Well, we can fit 18 electrons, right? Because we have 2 electrons per orbital, right? And there are 9 total orbitals or 9 total bunk beds. And then our final floor, right? Our final floor. Of course, we know we're always going to have an S. We're starting with our S sublevel. And then we go to our, well, let's actually do this. And we know our S sublevel only has 1 orbital, 1 bunk bed, right? Then we go to our P sublevel, and we know that's always going to have 1, 2, 3, right? We're only going to have 3 orbitals. And then we just learned our new D sublevel is going to have how many? 5. We have 5 bunk beds in this room. And then we have our final room. And this is the F sublevel, right? F sublevel. And I call that the fun one because it has 7 bunk beds. There are 7 bunk beds in there. So it's like the fun room. There's a bunch of people in there hanging out, partying, right? That's the fun room. And that would be up here on our 4th floor. So we still have our S, we still have our P, we still have our D, and then we add on to the end our F right here. We add in the F. So we need to figure out total number of electrons on that energy level. We have to add all these up. So let's do 1 plus 3, right, is 4. 4 plus 5, of course, is going to give us 9 bunk beds. And then finally, 9 plus 7 is going to give us 16 bunk beds. And of course, we can fit 2 electrons in every orbital or bunk bed, right? We can go ahead and do 2 times 18, or excuse me, 2 times 16, which is 32, right? 32 total electrons. And we'll even check our answer here. We'll insert an image of a Bohr model. If we just search Bohr model, we'll find a big one. Oh yeah, this one's huge. Let's use this one. So let's check our answers. So if I want to know how many electrons are on the 3rd energy level, right, our 3rd floor, I can go here. 1, 2. Here's our 3rd floor, right? We originally said there should be 18 electrons on the 3rd floor. Well, let's check our answer. We have 2, 4, 6, 8, 10, 12, 14, 16, 18. 18 full electrons because there's more than that, right? 18 full electrons. Awesome. And then we can even check our next one. Our 4th level should have 32, right, if it's full. So we start here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, right? 32. So this is essentially how we break it down. We're going to get way more into this in class. I know this might be a little confusing. It's a bit of a longer video. Trust me, I've made it twice now because I did the first time without audio. So if you guys have any questions, you can always message me. Tomorrow in class, we'll probably talk a little bit about the periodic table and how that helps us out and what orbital diagrams are. Believe it or not, you guys already know how to do this. You guys already know how to do that. So I recommend you watch this video, fill out this note page, and maybe refresh up on these videos here a little bit. All right? All right. Have a wonderful day.